Assalamualaikum, very good afternoon. Can you hear my voice clearly?
Waalaikumsalam, betul.
Afternoon,
Clear.
madam. Yes.
Okay, thank you. Okay, so today is week 11B lecture. So let's begin our class with assignment of Dua. Volunteer, please.
Al-Fatihah. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wa anshur alaina min hazaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Sallallahu ala sayyidina Muhammad wa ala alihi wasallam. Alhamdulillahirabbil alamin.
Amin Rabbal Alamin. Thank you very much, Amir. Okay, so let's continue on our lecture. Last Tuesday, we have covered on the converting transfer function in S domain to state space equation. And after that, we already sketched the signal flow graph to represent the state space equation. From previous example 7a, we have a transfer function, which the first case is you only have constant at numerator and polynomial function at denominator. And the second case, for example 7b, we have both polynomial function for numerator and denominator. Okay, for this one, like I briefly explained to you previous Tuesday before we end our class. So we need to do it part by part so that we repeat the 3 steps, okay, for first part and second part, then only we extract the information from the equation after we apply the 3 steps for converting transfer function to state space equation, and we construct the matrix A, B, C, and D if you have any. So again, let's refresh the 3 steps of the conversion procedure. The first one, you need to cross multiply both sides of the transfer function. So the output must be multiplied with the denominator, the input must be multiplied with the numerator. Second step, you need to take inverse Laplace transform. It depends on the variable. You will start with that variable, for example, C without dot, and then the next one, C dot, C double dot, C triple dot, which based on the polynomial order from your transfer function without S, meaning that there's no dot on the variable. S with the power of 1, the first order of the polynomial will contribute single dot to that variable. Second order polynomial will contribute double dot to that variable, and third order polynomial will contribute triple dot on top of the variable. And then we need to, in step number 3, we need to select a set of state variable. In this case, you need to decide how many variables do you have based on your denominator of the transfer function, x1, x2, x3. Then in order to complete a set of state variable, you need to differentiate your state variable. X1 become x1 dot, and then x2 you differentiate become x2 dot, x3 you differentiate become x3 dot. Okay, so you need to define how many state variable and then how many derivative state variable, x1 dot, x2 dot, x3 dot. Then you can construct your state space equation based on equation 1 and 2. Then you can start sketching your signal flow graph. To sketch your signal flow graph, okay, what is the first thing that you need to do? Apa dia? First step. Before you start sketching the signal flow graph, what is the first thing? Ideas? Anyone?
Check numerator, lepas tu cross multiply.
Macam mana, Balkis?
Check numerator je, lepas tu tengok whether dia cross multiply macam mana.
Untuk sketch signal flow graph. You sure? To sketch the signal flow graph, the first step is to calculate how many nodes that you need or required in that signal flow graph to represent the input, output, state variable, and derivative state variable. That will be your first step. Okay, then you refer to the equation that you determine in step number 3 and also the set of state variable to complete all the gains forward path, feedback path in your signal flow graph. Okay, thank you, Balkis. Okay, next, let's proceed. Any question from example 7A? The first example of converting transfer function to state space equation. Ada soalan tak sebelum saya move kepada example 7B? Tak ada soalan? Okay. So for example 7B, okay, like I briefly explained, saya dah cover sikit hari tu. So we need to check if you have polynomial function at your numerator, then you need to rearrange your equation into two parts, your transfer function into two parts. So in this case, instead of C over R, you rearrange to be equal to X1 over R multiplied with C over X1. X1 is your state variable, one of your state variable in this case. Okay, and so the first part, which is X1 over R, is actually 1 over denominator. Okay, and the second part, which is C over X1, is your numerator. So your numerator, now this one is your numerator. Okay, this one is your first part, 1 over denominator. The second part is your numerator. So settle the first part first. X1 over R using 3 steps. The first one, you need to multiply, cross multiply both of the transfer function. Okay, so X1 multiply with a denominator, input multiply with 1. Then you have this equation, which is equal to R. Okay, on the left side is your denominator function actually. Okay, now, second step, take the inverse Laplace transform. Again, check. Okay, so for 21s, sorry, this is 21x1 without s, then the variable x1 will maintain become x1. Okay, on the left side, 15s x1. This s contribute single dot. Okay, variable x1 maintain, and the polynomial s with the power of 1, the first order polynomial, will contribute single dot on the top of the variable x1. Then you take the coefficient together, it becomes 15x1 dot. The next one, 7s squared. So the squared function, the second order polynomial, will contribute double dot. Okay, then we have x1 because we have this variable x1, and then take together the coefficient 7. And the last one, the highest order polynomial is 3, then it will contribute triple dot for x1. Ada soalan? Boleh follow?
Boleh, madam.
Very good, thank you, Kelvin. Okay, next. Okay, before we proceed with the step number 3 to determine the set of state variable, you need to determine your state variable first. Okay, so to determine the state variable, start with the function without s, which is 21x1. So again, at this stage, you nak determine ada berapa state variable, x1, x2, x3, x4 ke, x1, x2 ke, x1, x2, x3 ke. Okay, so kat sini kita dah boleh guess if it is third order polynomial, you will have 3 state variable, x1, x2, x3. Kalau you ada second order polynomial, you akan ada two state variable x1, x2. Kalau you ada, if you have fourth order polynomial, you will have four state variable, state 1, x1, x2, x3, x4. Okay, so start with the function without s, 21x1, so they maintain x1. The next one dia akan jadi x2. Pergi sebelah kiri lagi dia akan jadi x3. And the highest one dia tak boleh jadi x4. Dia kena ada derivative state. In this equation, it must has one derivative state variable. So dia akan ambil the last one, x3. Differentiate, dia akan jadi x3 dot. Okay. Tak boleh, tak ada langsung derivative state variable dalam equation ni. Kena ada. Okay, coefficient maintain 1, 7, 15, 21. Okay, R, there's no polynomial function, dia tak ada RS. Okay, so they maintain sebagai R kat sini. Okay, sometimes the label for input can be used as U. So just use any variable that has been given in the transfer function as your variable in your state space equation. Okay, next, for step number 3. Okay, again, we rearrange the equation above so that we'll have one equation for x3 dot. Okay, this is for x3 dot. Okay, then we've done part 1, x1 over r, which is equal to 1 over denominator of the transfer function. Ada soalan untuk part 1? Ada? Semua okay? Okay, next.
Okay, madam.
Thank you, Kelvin. Okay, next, let's move to part 2, which is C over x1. For this one, you are actually analyzing the numerator part only. Okay, and then again, applies first step, cross multiply both transfer function. In this case, x1 will multiply with the numerator. Then we have this equation. Next, take the inverse Laplace transform. So check balik. For x1, the without s, it will be maintained as x1. 5s, it will become 5x1 dot. S squared x1, dia akan jadi x1 double dot. Okay, equal to c. C without s, dia akan maintain as c without dot. Okay, next, again, we determine the state variable. Start with 4x1, the function, the polynomial function without s. So this one become x1. On the left of the 4x1, it become x2. On the left of 5x2, it become x3 equal to c. In this case, c is your output. This is your output. So we need to consider that c is also equal to y in this case. Okay, any question for second part? Are you following me? Okay, next. Thank you, Ami. Okay, next. Let's determine our set of state variable in yellow box. Okay, so the first one. Okay, from this one, okay, on the first part, we can determine our set of state variable based on this one, which is x1 dot equal to x2. Okay, x1 dot equal to x2. The next one, x1 double dot equal to x3. Okay, and the last one, x1 triple dot equal to x3 dot. Okay, and if we take this equation and differentiate, it will become x2 dot equal to x1 double dot, where x1 double dot is also equal to x3. So we have this equation. So we have complete our set of state variable in yellow box. That's how you determine your set of state variable. Ada soalan? Okay. If there's no more question, let's construct our state space equation for matrix A, B, and C. So let's start with equation number 1 from part 1. Again, since we have 3 state variable, meaning that we also have 3 states, derivative state variable. So this is state variable x1, x2, x3. This is derivative state variable x1 dot, x2 dot, x3 dot. Okay, so from equation number 1, part 1, we already have equation for x3 dot, the third row. Okay, for the first equation. Okay, so again for column number 1, x1, column number 2, x2, column number 3, x3. For for matrix C pun sama, x1, x2, x3. Okay, so this is your input. Okay, now for the third row. Okay, so we fill up negative 21 for x1, negative 15 for x2, negative 7 for x3, and for input R, the coefficient is 1. Okay, the next one, we check for the second and first and third row. First and second row. Okay, for first and second row, you can check the equation, any equation that representing x1 dot. So check, we have one equation for x1 dot in the yellow box, our set of state variable. x1 dot is equal to x2 only. There's no relationship with x1, that's why 0. There's no relationship with x3, 0. There's no relationship with input, 0. The next one, we need to fill up for our second row for x2 dot. We have one equation for x2 dot, which is equal to x3. So for column, for the third column, we can fill up 1. So there's no relationship for x2 dot with x1. That's why we put 0. No relationship with x2. No relationship with input. Then we have completed our first equation for state space, x dot equal to ax plus br. In this case, r is your input. Okay, let's use our second equation for the second part. Okay, so C is actually equal to y, then we can refill this one for this equation, the second equation for state space. So we have 4 for x1, we have 5 for x2, we have 1 for x3. That's it. We have completed our state space equation. Senang ke susah? Senang ke susah?
Okay.
Senang kan? Senang je, tak susah.
Okay, got it.
Nah. Okay, now before we sketch our signal flow graph, what we need to do? What we need to do before we sketch our signal flow graph? Calculate how many nodes that we require. Okay, so 1 for input, 2 for output. We have 3 state derivative variables, 1, 2, 3, 4, 5, and we have another 3 derivative state variable, 6, 7, 8. So we need 8 nodes for our signal flow graph. Okay, so we have 8 nodes representing input, output, 3 state variable, 3 derivative state variable. Okay, so start label first draw your nodes and connecting all the nodes from the left to the right with a straight line. That one will represent your main forward path. Okay, so main forward path, you tengok dia punya, you check the arrow must be from the left to the right. This one. Okay, kanan ke kiri. Okay, yang ni tolong betulkan ya. Ini sebenarnya dia sambung ke sini. Sekejap. Okay, dia sambung dengan X1, dia bukan sambung dengan X1 dot. Tolong betulkan. Okay, dia sambung dengan X1 dot. Okay, so start label, the most left is your input R, the most right is your Y, which is equal to C. Di sebelah kiri output, you mesti start dengan you punya first state variable X1. Okay. Then, sebelah kiri X1, you mesti letak X1 dot. Next, di sebelah kiri X1 dot, you mesti letak X2. Di sebelah kiri X2, you mesti letak X2 dot. Di sebelah kiri X2 dot, you mesti letak X3. Di sebelah kiri X3, you mesti letak X3 dot. Which is, X3 dot is next to input. Okay, that's how you rearrange all the state variable and derivative state variable between input and output. Jangan salah letak susunan state variable and derivative state variable. Next. As I mentioned, from X3 dot to X3, you must apply the integration process. In this case, it will be represented by the polynomial function 1 over S. So between X2 dot and X2, you mesti letak 1 over S. Between X1 dot and X1, you mesti letak 1 over S. Okay. Okay, next. Let's use our first equation for X3 dot. Okay, our first equation for X3 dot, kalau you nak ambil daripada matrix A, B, C pun boleh, tapi lebih mudah you ambil daripada equation. Okay, equation 1 and equation 2. So ambil equation 1 dulu. Equation 1 is for X3 dot. So dia ada negative 7X3. So connecting between X3 and X3 dot and the gain is negative 7. The connection for X3 dot, which representing your denominator of the transfer function, must be in feedback path for this form of phase variable form. Okay. The arrangement for the state space equation for this one is phase variable form, meaning that the bottom row of the matrix A, okay, the bottom row of the matrix A, this one is same with the coefficient of the denominator of the transfer function in reverse order. That's why feedback and negative value. So you kena letak sekali negative value. Okay, because in reverse order tadi, you kena jadikan dia feedback. Okay, so negative 7X3 you dah letak, and then kita ada negative 15X2. So connect with between X3 dot and X2, you letak dia punya gain negative 15, and the last one is negative 21X1. Sebab tu yang ni salah Okay, so saya dah betulkan, sambung, please connect between X1 and X3 dot, and the gain is negative 21. Okay, so this one betul. Any question on the feedback path? Boleh? Okay, for the feedback path, make sure your arrow from left to, from right to the left. For forward, from left to the right. Okay, now let's use our second equation for the second part, which is from numerator. Okay, for this one, if you check, okay, y equal to 4x1, 5x2, 1x3. Okay, so dia akan jadi forward path. Kenapa forward path? If you check matrix C, dia ikut susunan numerator 4, 5, 1. Okay, dia ikut susunan numerator. Okay, so 4x1, okay, and then kita ada 5x2, and then the last one kita ada 1x3. So connection between y and x1, 4, the gain is 4. Connection between y and x2, the gain is 5. Connection between y and x3, the gain is 1. So we have completed. Okay, one more for equation 1 saya tak mention this one tadi untuk R. Okay, 1. Okay, the next one you kena consider equation from yellow box ni, set of state variable. Okay, between x3 and x2 dot 1, this one. Okay, ni cara baca dia ialah x2 dot sama dengan 1x3. In this case, yang di sebelah kanan, okay, which is x2 ialah, in this case, kalau cara kita nak baca ialah x2 dot ialah output. 1 ialah gain, x3 ialah input. Okay, this is how we write the equation. Okay, next one, between x1 dot and x2. Okay, this one, this equation. So, kita letak 1 dekat sini. So, then we have completed our signal flow graph. So, you kena letak semua gain tu. 1 kalau tak letak, tak apa. Asalkan you tak confuse. Okay, but this is the complete one. Ada soalan? This is the complete signal flow graph for example 7b, where you have both polynomial function at numerator and denominator. Ada soalan? Tak ada? Kalau tak ada soalan, saya move ke next slide boleh? Thank you, Kelvin. Okay, now, okay, previously in example 7, we convert from transfer function to state space equation. Now we have to do a reverse process. If you are given state space, how to convert to transfer function? We have to use this formula. Formula ni memang ada pada slide example 8. Okay, dia tak ada pada slide lain. Okay, so to determine the transfer function G S equal to matrix C multiply with matrix Si minus A, the inversion of matrix Si minus A multiply with matrix B plus D. D kalau you ada, in this case you tak ada D, you tak ada. Ni pun tak ada D. Okay, so you do not have this part. Okay. So identity matrix will follow the dimension of matrix A. Dia akan follow this one. So if matrix A 3 by 3, then identity matrix 3 by 3. For example B, matrix A is 2 by 2. So identity matrix is 2 by 2. Okay, let's do example A. Okay, for example A, as I mentioned previously, if you want to save your time during final for question 3 for set space, you can construct directly your matrix Si minus A. Kalau you nak letak S, lepas tu nak construct matrix I, lepas tu minus A, lepas tu baru nak darab S dengan I, lepas tu baru nak construct Si minus A, you akan ada 3 lines. So instead of writing 3 lines of the calculation, you can directly construct your matrix Si minus A. Make sure you dah familiarize, you kena practice. Okay, kalau tak dia akan jadi sedikit lambat dan you akan tak cukup masa untuk jawab semua soalan. Now for example 8A, let's construct our matrix Si minus A. Okay, so this is matrix Si minus A. You know that Si is a 3 by 3 matrix as multiplied with the identity matrix. Okay, this is if you directly write the answer for matrix Si minus A. So you skip 2 lines in your answer script. Okay, now to determine the next part is you need to determine your inversion of matrix Si minus A. So what is the formula to determine the inversion matrix of this one? What is the formula? Si minus A inversion is equal to check your lecture notes. What is how to determine?
Adjoint A over determinant A.
Very good, Rushaidi. Okay, so adjoint matrix Si minus A divide by the determinant Si minus A. So how to determine the adjoint for this matrix? This is 3 by 3 matrix. Cofactor of matrix Si minus A, then you transpose. Okay, if it is matrix 2 by 2, you can directly determine the adjoint of that matrix. But this is 3 by 3, then you need to determine the cofactor of that matrix first and then transpose. Okay, so let's determine the cofactor of matrix Si minus A. This one Dr. Shakrin dah cover last week. Okay. So let's start our arrangement of the cofactor. So this is plus. The second one dia akan jadi minus. Third one dia akan jadi plus. For second row dia akan start dengan minus. The next one plus. The next one minus. For the third row, it will start with positive polarity first. The next one minus. The next one plus. Okay, so this is the structure based on the polarity for each column and row. And then after you determine this one, you have to transpose to get the answer as the adjoint matrix. So for this one, check betul tak saya buat. Okay, this is the first technique. For the first time, Dr. Shakrin showed you how to determine this one. You kena tutup row, you kena tutup column. But in final assessment, during the assessment, you need to do it very quickly. So use your imagination. You are closing that line, that row and that column to construct the determinant structure for each column and row to construct the cofactor matrix. Betul tak saya punya cofactor structure?
Betul,
Ada
Miran?
saya tersalah kat mana-mana?
Tak ada.
Okay. So you kena practice buat dengan cepat. And the next one you calculate the determinant. For this one, then baru you transpose. Saya sambung sebelah ya. Okay. So this is the adjoint of matrix Si minus A. Okay. Then for this one, I advise you to assume that this adjoint matrix, since we have a few polynomial function until second order, then you can represent this adjoint matrix as alphabet A, B, C, D, E, F, G, H, I for this 3 by 3 matrix of the adjoint Si minus A. Okay. Later, I'll explain why we have to do like this to represent the 3 by 3 matrix of adjoint with the alphabet only. Any question on adjoint matrix? Okay. Later, as you can revise this example, determine the cofactor, calculate the determinant, and transpose the matrix. Make sure the calculation is correct, and you have to do it quickly during the final. Okay, now let's determine the determinant of Si minus A. So check your Si minus A matrix, this one. Okay, determine the determinant of Si minus A. I prefer to use second method, so it's up to you. There are 3 methods, just choose one of them which you are comfortable that you can help you to do it quickly and correctly during the assessment. As long as the final answer of the determinant is correct. I'm using second method. I add the first 2 rows on the right of the matrix. Okay, now we have adjoint matrix. We have determinant Si minus A. Any question before I proceed to the next step? Ada soalan? Next, you can construct your transfer function. Okay, GS equal to matrix C multiply with the inversion of Si minus A multiply with matrix B. In this case, there's no matrix B given in the state space equation. So we can just leave it our equation to determine the transfer function in S domain like this. Okay, now let's use matrix C and B. Okay, kita tak guna lagi matrix C and B. So our matrix C 1 0 0, matrix B 10 0 0. Okay, now matrix C 1 0 0. So multiply with the inversion of matrix Si minus A. The inversion matrix is adjoint matrix divided by determinant. So in this case, this is your adjoint. Okay, so we already represent our 3 by 3 adjoint matrix with label A until I. Okay, by using this representation, it can save a lot of your time. Divide by Si minus A, just put the symbol first. Do not put plug in the value of the polynomial function, and then multiply with matrix B 10 0 0. Based on this one, you need to analyze at this stage. After you construct your equation to determine the transfer function, you plug in your matrix C, inversion of matrix Si minus A, and matrix B. You need to analyze which part that you want to analyze first and which one you want to analyze later. In this case, between matrix C and B, okay, you can choose the matrix that has more zero values. Lebih banyak zero dalam matrix tersebut, you pilih matrix tu antara C dengan B untuk you settlekan dengan matrix Si minus A. Sama ada you nak settlekan matrix C dengan Si minus A, inversion of Si minus A dulu, ataupun you nak settlekan dengan matrix B. Okay, nak pilih matrix yang mana lebih banyak nilai zero, lebih mudah. Okay, you nak buat mana-mana pun boleh, tak ada masalah. Tapi tips saya ialah settlekan dengan matrix yang lebih banyak zero. In this case, pilihan you A atau B? Which one? A atau B? Tak ada pilihan.
B.
Dua-dua dia setara sekarang. Okay, for matrix C it has 2 zero values, matrix B has 2 zero values. Okay, you boleh pilih mana-mana, A betul, B betul. Okay, dia lebih mudah. Okay, sama je. Okay, so in this case, let's say if I want to settle down the inversion of Si minus A with matrix C first, katalah saya nak settlekan dengan matrix C dulu. Okay, so cara dia ialah the first column of matrix C multiply with the first row. Yang ni make sure tahu ya, row darab column ke, column darab row ke. Okay, second column multiply with second row. Third column multiply with third row. So in this case, kita punya calculation akan jadi A, B, C divide by Si minus A multiply with the matrix B. The tall matrix 10 0 0. See? That's why I suggest you to represent your adjoint matrix by alphabet A, B, C. So you takkan buang banyak masa untuk tulis polynomial yang panjang-panjang. S squared plus 5s plus 3. And then you ada lagi add another row and column, another polynomial function, second order polynomial function. So by representing that adjoint matrix with A, B, C, it will save more of your time. Okay. Okay, now we want to settle down the matrix, adjoint matrix ABC with matrix B. So our transfer function ialah 10A divide by SI minus A. Dan kat sini barulah you plug in nilai yang sebenar. So 10A ialah, okay, you darab terus, saya darab terus 10S squared plus 30S plus 20 divide by the adjoint matrix, the determinant so this is your transfer function in S domain based on the given state space equation in the question. Ada soalan?
Madam.
Yep.
Nak tentukan dia matrix ABCD tu guna state space equation tu kan, Madam?
Guna state space equation tak? You letak je ABCD.
Tak payah.
ABCD
yang
apa yang dalam ni? Dalam transfer function.
Yang tu.
Yep. State space equation.
Oh, okay.
Betul. State space equation diberi dalam soalan. Jauh nak sampai ke slide jauh. Ni ialah state space equation. Because for this question, you need to convert from state space equation to transfer function. So this is your transfer function. Matrix C, matrix A, matrix B, matrix D ialah daripada state space. Good question, Rushaidi. Thank you. Yang lain ada soalan? Okay. So in this case, there's no matrix D given, so tak ada, you tak perlu guna dalam equation. Kalau diberi D, then tambah dengan D. Okay. Jarang matrix D ada because selalunya untuk output matrix, there's no relationship between Y and U. Dia tak ada direct relationship, dia tak ada connection between input and output. Okay, input dan output dia tak ada connection, so matrix D biasanya tak ada, tak wujud. Okay, so kalau you nak study nanti, you pergi ke sebelah kanan ni lagi. Okay, sampai jumpa this one. Okay, let's say, katalah yang tadi tu saya nak settlekan dengan inversion matrix inversion matrix SI minus A dengan B. Okay, so kena buat satu-satu, kena careful. Dia punya cara ialah lain sikit. Yeah. Okay, for that one, kalau you nak settlekan inversion matrix dengan B, so ni darab ni. And then first column darab dengan first row, second column darab dengan second row, third column darab dengan third row. Sama juga you akan dapat 10, dia akan dapat 10 A, D, G. Okay. Dan you darab dengan matrix C, dan dia tetap akan dapat 10 A. Ada soalan? Okay. Okay, this is if you use if you want to convert from space equation to transfer function. Okay, untuk example 8B 2x2 saya nak buat sendiri. Kita dah cover 3x3 dimension. Okay, let's take 5-minute break before we proceed with the example 9, 10 and 11.
Okay, Madam.
Okay, let's continue in example 8. Okay, for example, example 9. Okay, for example 9, instead you're given the state space equation. For this one, the state space equation is not directly given in the question, but you are provided with a signal flow graph sketch. Then you need to extract the information until you can construct your state space equation. Then only you can convert from state space to transfer function in S domain. So from the signal flow graph, okay, for example 9A, okay, this is the signal flow graph. Okay. Okay, this is your signal flow graph. Make sure you extract the information correctly from the signal flow graph. Do not miss any information in constructing the state space equation. So this one is a seesaw system, single input U and single output C. Okay, this is seesaw system, single input, single output. For this one, okay, on the most left is your input. On the most right, C is your output. You also have to know that C is equal to Y because in the state space, in the second equation of the state space, you'll be using variable Y for the output. Okay, for this one, you can analyze that in this signal flow graph, we have three state variable, X1, X2, and X3. At the same time, we also have three state derivative variable, X1 dot, X2 dot, and X3 dot. Okay, so you can already imagine our matrix dimension for matrix A is 3 by 3 since we have 3 state variable, 3 derivative state variable. Okay, but for now we have to extract the equation first from the signal flow graph. So always start your equation from the most right. Ni daripada output ni dulu. Start daripada sini. Okay, in this case you have to construct your equation for y or c. Y equal to c equal to, okay. So c sama dengan apa? Keluarkan equation daripada signal flow graph class. Anyone would like to try? C equal to
X1.
X1 lagi. C equal to X1. Cukup? Dah cukup?
2x2.
2
2x2.
plus 2x2. Ni, you nampak ni. Ada dua yang masuk ke C. Satu daripada X1, satu lagi daripada X2. So, kena baca sekali dengan dia punya gate. So, C equal to YX1 plus 2x2. Okay, this is your first equation. Okay, so ambil yang pertama dulu daripada Y ataupun C. Second, you kena check you punya first derivative state variable. Kenapa kena check derivative state variable? Sebab you nak construct you punya state space equation that X1 dot, X2 dot, X3 dot. So you kena cari ni dulu dengan ni. Y ni tadi kita dah dapat dah. Okay, so Y kita dah dapat nombor 1. So sekarang cari ni yang derivative state variable ni sebab so that we can fill up our matrix. So second, kita cari kita punya X1 dot kat sini. Okay. So x1 dot equal to sama dengan apa? X1 dot sama dengan X1 dot sama dengan
X2.
X2.
very good. X1 dot equal to X2. This is our second equation. Okay. Then kita cari X dot X2 dot. Okay. So second kita dah cari ni. This one is our X2 dot. So X2 dot sama dengan
X3.
very good. X3. This is our third equation. Okay. Now kita cari X3 dot. Okay. X3 dot sama dengan
Negatif 8X3.
X3 dot equal to, kita baca daripada X1, negative 2X1, lagi
Negative 19X2.
yes, lagi
Negative 8x3.
very good. And lagi ada satu lagi tertinggal.
Plus R. U.
You kena pakai apa-apa variable yang dia bagi. Okay, so this is our fourth equation. Okay, done. Dah boleh construct you punya matrix. Okay, so construct you punya matrix X1 dot X2 dot X3 dot. Yang ni you dah faham dah, you dah boleh buat cepat dah. Plus B U Y equal to, oh sorry, you kena ada this one, X1, X2, X3. This one pun sama. Okay, from the first equation, Y equal to X1 plus 2X2. Then, second equation, X1 dot equal to X2 only. Okay. Third equation, X2 dot equal to X3 only. Kan? Fourth equation, X3 dot equal to negative 2X1, negative 19X2, negative 8X3 plus 1U. That's it. This is our state space equation. Then you can proceed with the determine the adjoint of matrix Si minus A, divide by calculate the determinant of Si minus A, then multiply with matrix C and B. Okay, daripada sini you dah boleh construct. First one, determine the cofactor first. Okay, you ingat step dah. You construct Si minus A matrix, and then determine number second, determine the adjoint of Si minus A, which you determine the cofactor of Si minus A, and then you transpose. Then the third one, you determine your determinant. Then the fourth one, you dah boleh construct C, this one adjoint Si minus A, divide by determinant, multiply matrix B plus D. matrix B plus D. Okay, the same procedure as in example 8A yang kita dah buat tadi. Boleh try this one? Saya nak you try sendiri ya. Okay, now I want you to try construct the state space equation for example 9B. Okay, untuk example 9B, okay, for example 9B, we have MIMO system. Mana saya punya tadi? Okay, for example 9B, we have MIMO system. Okay, so this MIMO system meaning that you have multiple input. You have U1, U2 as your input and you have multiple output Y1 and Y2. Okay, for this example, make sure you extract the equation correctly. Semua information you dah ambil, semua line by line you dah go through sampai you determine the equation. So this is example 9B. Okay, you nak start dari mana? Nak start dari mana? You ada MIMO, you ada 2 input, you ada 2 output. Ada idea nak start dari mana?
Dari Y1.
Very good. Always start from the output. In this case, kita ada 2 output, so Y1 and then Y2. So let's analyze our output Y1. Okay, Y1 equal to
X1.
X1. Very good. Ada lagi tak? Ada lagi?
Dah.
Tak ada. Okay, this is the first equation. Next, Y2 equal to
X2.
X2. Okay, so this is MIMO system. Y2 equal to X2, this one. Okay. Next, so we've done with the output. So yang ni nanti kita akan construct matrix C. So next one, kita nak analyze apa?
Input.
No. Derivative state variable. First, you cari output, you keluarkan dia punya equation. Second, you cari derivative state variable. Yang ni sebab kita nak construct the first equation. X1 dot sama dengan apa, X2 dot sama dengan apa, X3 dot sama dengan apa. So that we can construct our matrix A and B. Kita cari equation untuk output, kita nak construct matrix C dan D kalau ada. Okay, so cari derivative state variable. So ni nombor 1, ni nombor 2, 3, 4, 5. Okay, now let's analyze our X1 dot. Sama dengan, macam mana nak baca tu? Output equal to gain multiply with input.
X2.
Very good. 2x2. Ada lagi? Tak ada.
Tak
Okay,
ada.
done. This is equation number 3. Okay. The fourth equation, X2 dot. Sama dengan X2 dot sama dengan
X3 tambah U full.
very good. 2x3 lagi.
Plus X2.
U2.
Boleh kuat sikit tak? Nah, mana lagi? Ada lagi. You tengok apa yang sambung kepada x2 dot tu.
Tambah U2.
U2, very good. Lagi? Tak habis lagi.
Tambah 2x1.
Very good. This is how you analyze. Jangan ada yang tertinggal. You ada yang tertinggal, you punya state space equation tak complete. Okay, so susun balik 2x1, 2x2 tak ada, tambah 2x3, tambah u2. This is our fourth equation. Boleh? Yang lain-lain? Okay, please analyze carefully. Make sure you guna semua information. For this one, untuk x2 dot, you tengok line mana yang sambung dekat x2 dot ni. So, you kena ambil signal tu untuk masukkan dalam equation. Okay, next, let's move to the fifth equation, the last one, x3 dot. So, sama dengan apa dia? Sekejap, saya tengah nak fahamkan equation. Equation negatif 3 kali 3. Oh, negatif 3x3. Okay. Saya negatif 3x3. Betul. Plus x2. Plus 2u1. Very good. Okay, so susun balik. x2 minus 3x3 plus 2u1. Thank you, Amir. Ada yang lagi tertinggal? Tak ada? So, dia punya construction untuk state space equation is a little bit different compared to example A. Because it's for MIMO system, we have 2 input and 2 output. So, our state, derivative state variable tetap sama. Kita ada 3. We have 3 derivative state variable. Our matrix A is 3 by 3 since we have 3 derivative state variable x1, x2, x3. Kita construct dulu dia punya structure. Plus, this is our matrix B, right? Okay. Untuk matrix B, kita ada U1, U2. Okay. So this is matrix untuk equation untuk output. So kita ada y1, y2. So 2 by 3 matrix multiply with x1, x2, x3. Kita tak ada matrix D. Okay. As usual, for matrix A, the first column is for x1, x2, x3. For matrix B, the first column is for u1, the second column is for u2. Okay, for matrix C, sama juga first column x1, x2, x3. First row for matrix for y1, second row for y2 untuk matrix C. Okay, now let's fill up our state space equation based on our equation 1 until equation 5. Okay, so let's start with equation number 1. y1 is equal to x1, 1, 0, 0. Okay. Y2 is equal to x2, 0, 1, 0. Okay, now let's move to equation number 3. X1 dot is equal to 2x2. Done with equation number 3. Let's move to equation number 4. X2 dot is equal to 2x1 plus 2x3 plus u2. Okay, that's why when you write the equation, make sure you arrange from the first state variable x1, x2, x3, u1, u2. So when you transfer the information from the equation to the matrix A and B, it follows the arrangement by column x1, x2, x3, u1, u2. Next, move to equation number 5 for x3 dot equal to x2. Negative 3x3 plus 2u1. That's it. Then we have complete our state space equation for MIMO system. Multiple input, multiple output. We have two input u1 and u2, and we have two outputs y1 and y2. Okay. So example 9 ni saya bantu you untuk extract equation dan construct you punya state space equation sahaja. Then you can proceed with the converting from state space equation to transfer function using the formula G as equal to matrix C multiplied with inversion of Si minus A multiplied with B plus matrix D. Any question for example number 9? So example 8, you are given directly the state space equation, convert to transfer function in S domain. Example 9, you are given a signal flow graph, so you need to determine the equation first before you construct the state space and then convert to transfer function in S domain. Then, okay, next for example 10, this one you are given the equation. Then you can directly construct your state space equation. Yang ni senang je. Okay. You dah boleh construct directly X. Okay. Okay, for this one, if you analyze, you have three state variable. Okay, you have three state variable, x1, x2, x3, and you have three derivative state variable. So you can guess that the structure of your matrix A is the dimension of 3 by 3. Same goes to if you check the equation for the output Y, it consists of x1, x2, x3, three state variable, then matrix C is 1 by 3. Okay, so this is your R. Okay, Y equal to so let's fill up our matrix. So for x1 dot 2 negative 5 3 2. For x2 dot negative 6 negative 2 2 5. For x3 dot 1 negative 3 negative 4 7. For the output equation negative 4 6 9. That's it for our state space equation. Okay, you can repeat for example B. Okay, for example B, this is actually equal to x1 dot the derivative state. Differentiation of variable x1 over the t, then it is x1 dot. Okay, this one ialah x2 dot. And so for example B, what is the dimension of your matrix A? For matrix B, what is the dimension of matrix A? If you check the equation.
2 by 2.
2 by 2, because you have two state variable x1 and x2, and you have two derivative state variable x1 dot and x2 dot. Very good, Balkis and Ami. Okay, so you check how many state variable that will determine your dimension of matrix. So let's move to the last example for today, example 11. Okay. This one you are given, ni macam tak related sangat dengan state space. This one you are given this information of the Bott table. Yang ni kalau untuk soalan frekuensi Response sesuai. Saya pun tak tahu kenapa example ni ada dalam ni. Tak apa, kita analyze ya. As a revision. Okay. So for this one, you can directly determine the transfer function without need to know what is the state space equation. Okay. Yang ni you boleh determine the transfer function in S domain directly from the Bott table in frequency domain. So for the first one, GS is equal to berapa? Analyze. Sometimes for frequency response, frequency response question, instead of giving you the direct open loop transfer function in the question can give you the information in terms of Bott table. Then you need to determine your open loop transfer function and start your Bott plot sketching. So for this one, you have 0 at 2, you have pole at 6, you have pole at 10, you have pole at 0. So this one you boleh tambah K untuk unknown gain. Boleh juga, tak letak pun tak apa. Okay. How about the second part? The second table. You have constant for theory number 1, 26 dB. How to use that information of the gain 26 dB from theory number 1, the constant. This is theory number 1. So the slope for all the frequencies is 0 dB per decade. How to use this information to determine your transfer function?
Log K.
Very good. 26 dB is equal to 20 log K. Please calculate what is the value of K for me. Berapa nilai K?
20.
K equal to 20. So you boleh terus guna 20 untuk S domain transfer function.
Tak,
Very good. Kenapa tak, Balkis?
sebab yang normal yang bahagi dengan 5 dengan 70.
Very good. Good observer. Okay. So that one, dia ialah sebenarnya dalam frequency domain. So this one 20 tu tadi ialah K divide by 5 multiply with 70, then you dapat 20, then you buat 20 log K, you dapat 26 dB as your final constant numerator. Okay. So you kena kira K pula. Berapa nilai K kalau you nak tulis dalam S domain transfer function? Berapa nilai K?
RM7,000.
Very good. Yang ni baru you boleh directly tulis untuk S domain transfer function. So S plus 5, S plus 70. That's it. Okay. So saya rasa itu saja untuk hari ini. Ada soalan sebelum saya habiskan kelas? So next week kita akan sambung the next slide. Okay. Signal flow graph ni saya dah cover sikit untuk you jawab soalan example 7. So you boleh sketch signal flow graph after you construct your state space equation. Okay, kita dah cover sampai sini. This one, if you want to construct your signal flow graph from the differential equation in terms of x1 dot, x2 dot, x3 dot, y, yang ni sama macam you construct daripada step number 3, you ada x3 dot and then you ada set of state variable in the yellow box tadi. Untuk example 7, you dah boleh construct you punya state space equation macam ni. Okay. Untuk next week, kita akan cover another representation for the state space equation. Before this, for example 7, we have a phase variable form punya structure. So there are the three form for state space equation. The first one is CCF, controllable canonical form. Second one is observable canonical form, OCF. The third one is diagonal canonical form, DCF. So soalan boleh minta mana-mana form untuk state space equation. So you kena tahu dia punya pattern, macam mana nak susun the roots from the transfer function daripada denominator, daripada numerator nak susun dalam bentuk macam mana. So you kena tahu. And then boleh juga soalan minta you briefly explain what is phase variable form, what is controllable canonical form, observable canonical form, diagonal canonical form. Dan yang terakhir ialah to determine whether the system is controllable. Kita boleh observe dia ataupun tidak. Controllability and observability. So kita akan habiskan next week insya-Allah. Lepas tu kita boleh proceed dengan tutorial with the discussion for the past year question. From question 3, okay, untuk state space question 3. So assuming that in final question 3 you need to finish within 30 minutes, and sama dengan soalan keempat, digital control, you need to finish within 30 minutes. That's it for today. Last call, any question? Ada? Okay. So please prepare for test 2. Saya dah siapkan soalan. Kalau study ada soalan boleh tanya saya untuk frequency response design. That's it for today. Let's end up our tasbih kafarah.